Hello guys, welcome to Friends in Tech Automation YouTube tutorials. And in today's video, we want to start by introducing the introduction to ladder programming language. So in our previous video, we created a project and we call it YouTube tutorial project. So if we open this project YouTube tutorial, just open the project here. So after creating your project, we added a controller, basically a device, that is step 7 400. So after adding your PLC, now it is the time to program that PLC, to write instructions to that PLC. Now we have different programming languages. Let's just open this project first. So here. So you can go to configure device. Then you can see we have one device here, PLC underscore one. This device we added in our previous video. So you can check our previous video. There's a link up there. So you can check our previous video. We added this PLC underscore one step 7 400. So let's just open this PLC. In that video, we explain how to add IO cards or IO modules. Also, I explain how you can add power supply unit to your rack so that you can make a complete PLC station. So we say that a complete PLC station entails power supply, PLC CPU, PLC IO modules, and PLC communication modules. So this is a complete station. It's a complete rack. So you have your power supply, you have your PLC, and your digital analog inputs, outputs cards. And additionally, you have your communication module here. So after adding your PLC, now it is time to program this PLC. Because remember, PLC is an industrial computer, but it cannot work without instructions. So you have to write instructions. Basically, you are telling PLC, do this 1 2 3. The process of telling PLC do 1 2 3, that is what is called PLC programming. Now, according to IEC standard, here, standard 61131-3, it highlights 5 languages for PLC programming, and the first one is ladder diagram, structure text, function block diagram, instruction list, and sequential function chart. All right. Now we want to start with ladder diagram. This here, ladder diagram. Now, what is ladder diagram? So ladder diagram is one of PLC programming language. All right, ladder diagram is one of PLC programming language. So what is this ladder diagram? So ladder diagram is a graphical programming language. Structure text and instruction list, those are text-based programming language. But ladder diagram, function block diagram, and sequential function charts, those are graphical programming languages. Now, ladder logic is a graphical programming language that represents a program by a graphical diagram based on the circuit diagrams of relay logic hardware. That is the most important thing. One thing is that PLC was designed to be used by engineers with limited computing or programming knowledge. So instead, what happened is relay logic was translated directly to ladder logic for easy understanding. Now, if you come to your TI portal, you can see we have PLC underscore one CPU 414-3PN stroke DP. Now, this here, if you expand on this folder here, we have program blocks. So program blocks, this is where you'll write your PLC program. So under program blocks, we have main block. So this main block here, this is where you need to write your PLC program. So if you double click, if you open main block here, just a minute. So if you open main block here, So remember, the purpose of this video is to try to explain what is ladder programming language. I will try to explain what is normally open, what is normally closed, and what is a coil, or sometimes we refer to it as assignment. Okay. So if you open main, this is what you'll get. This here. So this is ladder diagram. So by default, the programming language is ladder diagram. But remember, you can always switch these programming languages anytime. But by default, it is ladder programming language. But you can just come here, then you can switch. You see, right click your main block, then switch programming language. So instead of using ladder diagram, we can use FBD. That's it. Now you can use FBD. If you don't want to use FBD, again you can right click, then you can switch to use STL. So here, this is where you can write your FBD, function block diagrams. So I'll just switch back to ladder diagram because that is the whole purpose of this video. So it's switch to ladder diagram. That's it. Now, let's try to understand ladder diagram conventions, because it is very important to understand ladder diagram conventions. So I just highlight few here. These are ladder diagram conventions. The first thing, the vertical lines that you see in that video, in this entire portal, the vertical lines represent the power rail. Okay, so this here is a power rail. The vertical here, this is a power rail. Then the horizontal line, this here, this is where you connect your elements. All right, this is where you connect your elements. Sorry. Then this whole thing here, this is called network 1. Okay, this is called network 1, or sometimes you can call it rank 1. So network 1 or rank 1. So network 1 dictates one complete operation. Network 1. Now, so each rank on ladder defines one operation in control process. So network 1 defines one complete operation. Now, what is this one complete operation in process or in control system? What is one complete operation in control system? Now, or what? So we say here that one complete operation, that means that each rank must start with an input. You really have to understand this here. Each rank must start with an input or inputs and must end with at least one output. Then that qualifies to be a complete operation. All right. So in your network here, you must have at least one input and at least one output. I mean, you can have several inputs, but you must have at least one output. So you cannot just add one output without an input and call that a complete network. That's not a complete process. Why? Because even a switch, or just to turn light on off, at least you need a switch first, then you need an output, which is a lamp. That's the basic system you can have, turning light on off. So you must have a switch and you must have a lamp, which is an output. So that's just a direct connection, but still we have one input and one output. That's a complete operation. All right, that's one complete operation. Then another convention here is that electrical devices are shown in their normal condition. For example, if you are using a normally closed switch, then in your IDE, NTI portal, you have to represent it using normally closed contact. Okay. If you are using a normally open switch, then in your TI portal, you have to represent it as normally open contact. That's clear. Good. Then another thing which is also very fundamental here is that inputs and outputs are identified by their addresses. Inputs and outputs are identified by their addresses. This is very important. Now, we are saying that ladder programming is just translating relay logic. All right, it's just translating relay logic. Now, what we have here, Let me show you an example of a relay logic. So this here, this is just to start a motor. So this is the diagram or the electrical circuit for starting a motor, DOL, direct online method of starting a motor, an induction motor. So what we have here, this is three-phase, L1, L2, L3. Then you have MCB, just your breaker is here. Then you have contactor, so this is contactor here. Then you have overload or thermal relay. Then you have your motor. So that is the power circuit. No, so you need to start your motor and you need to stop your motor as well. So you need start push button. So this is stop push button, and you need start push button. Now this kind of logic, this is what is called hardwired relay logic. All right, this is hardwired relay logic. So the first thing, we are tapping one phase here. You can see we are tapping a phase. Then we are passing it to 95 of overload. That is normally closed of overload, 95. Then we are giving out 96. Okay, so out of from pin 96 of overload, we are taking it to stop push button. Then from stop push button to number 3 of start push button. From number 3 of start push button all the way to normally open the auxiliary contact of contactor, that is number 1. At the same time, we are feeding it to A1, the coil. Look at this connection here. So from number 4 of start push button, we are feeding it to A1. At the same time, we are feeding it to normally open, that is normally open contact of contactor. Then the other side of normally open, we are getting it back to stop push button number 2, pin number 2. Then we are just feeding neutral to A2. So that is the relay logic. That is the logic. Why? Because now if I run this simulation here, I'll turn my breaker on. Then if I click start button, let me just click start button here. So you see motor is rotating clockwise direction. So you see the motor is moving clockwise direction. Okay, is it rotating or revolving in clockwise direction? If I hit stop, that's it, the motor is stopped. Now this is what is called relay logic, hardwired relay logic. Now I want to translate this into ladder diagram. Okay, so ladder diagram, based on these conventions here, we are saying that you must have the vertical lines. So the vertical lines of diagram represent the power rails between which circuits are connected. So the first thing, I will draw those power rails. So I'll just stop simulation here. Then I will go to ladder. Then the first, of course, the first must be positive. So we must have positive rail. Then we must have negative rail there as well. That's it. So after doing that, you have to select. So I just draw just a minute here. One for power rail, positive rail. So that is positive rail. Then another one for negative rail. Perfect. Perfect. Perfecto. 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 Now, so let's check the control circuit of this or the relay logic of this circuit here. The relay logic of this circuit here, you realize that the first thing, we have overload. So from the supply or from one phase, we are taking it to 95, 96 of overload. Now 95, 96 of overload is normally closed. It's NC, okay? It's normally closed. So I'll use normally closed to represent 95, 96. So I'll drag normally closed here and place it here. So that is overload. So this here, this normally closed here represents normally closed of overload, that is 95. 95, 96. And we can just rename it as OR. So you can just rename it as OR, that is overload relay. Okay, so this is overload relay, or sometimes you can call it thermal relay. So from overload relay 96 all the way to stop push button. So we know that stop push button by default it is normally closed. Stop push button. If you check continuity of stop push button without pressing the button, it is normally closed. So again, I will use normally closed here to represent stop. That's it. Then we can name it stop. That's it. Then just click OK. Perfect. Then from stop, we are taking it to start. So again, if you check continuity of start push button is normally open. So I'll use normally open here. So this normally open here will represent start. So just double click this, then change this to start. That's it. Okay. So from start, look at this. From start, that is from number 4, we are taking it to A1. Now A1 here, this is the coil of this contactor. So how do we represent coil in ladder diagram? We use this symbol here, okay? This. So this here represent coil. All right. So that represent coil of what we call an assignment. And we can name it KM1, negative KM. KM, that's it, because that is contactor. Perfect. And we can just complete this connection. That's it. That's it. Now, take a look at this here. From start, we are feeding it to A1. At the same time, we are feeding it to 13. That is the auxiliary contact of this contactor. So 13, 14, that is normally open. That is normally open. So I have to represent this with normally open, and you can see they are in parallel. So 13, 14 is in parallel with A1, A2. So I have to put it in parallel with start. That's it. That's it. And it is what? This is normally open of Km, of minus Km. So I just have to rename it minus Km. That's it. Minus Km. That's it. So from start, directly from start, we are feeding it to 13. So I'll just connect this way. That's it. That's it. Then the other end, we are feeding it back. So this is to stop, and the other to start, like that. So guys, what we have done here, we have just translated this relay logic, the hardwired relay logic, into ladder diagram. So this is ladder logic, or what is called ladder diagram. So if we simulate this, what happens? So what will happen if I click start? Perfect. So clearly you can see that your contactor is energized. That means that your motor is running, and you can confirm down here that your motor is running. So if I break this, so I can click stop. See, that's it. So this is just a simple DOL, or sometimes we call it latching circuit. Okay, click start, stop, start, stop, start, stop, stop, stop. That's it. Now, thank you, thank you, thank you. That's it, that's it, that's it. So we want to write the same program in TI portal. So what we have done, so we have used something, we have used normally open, normally closed. So what are these normally open, normally closed? Now, so normally open contact, this refers to an input device or contact that is in its open state when there's no actuation or signal present. So sometimes we just call it an open circuit. Okay, it's just open. Then normally closed refers to an input device or contact that is in its closed state when there's no actuation. So if you provide power, then you will just complete the circuit. So you can refer to it as a short circuit. Okay. Now in TI portal, on your right hand side, we have instructions. Then we have bit logic operations. Okay, we have bit logic operations, so we have this folder. But before bit logic operation, we have general. So under general, this is when you want to add another network. For example, if you want to insert a new network, you can just drag and drop it here, and you'll have another network. Okay, sorry. Supposed to drag what's not happening. Okay, good. So you can insert a network by doing that. You can insert an empty box by just doing that. So that's an empty box. So this is general. Okay, this is general. This is general. But now we'll start with bit logic operation. So normally open, normally close, you find them in bit logic operation. So under bit logic operation, we have normally open. So we are saying normally open is just an open circuit. So it will provide zero state at its default state. So it can represent an input. Actually, it represents a digital input. So this digital input, at its default state, it will give a signal of 0. All right. So after some changes, then it changed the state from normally open to normally closed, giving a signal of 1. So you can just drag this contact here. That's it. So you see we have normally open here. All right. Then we have contact. So this is what is used to represent an output. Okay. So this here. So this is an assignment. Sometimes in TI portal call it assignment, but it's just an output. So it's a coil. Okay. It represents a coil. So you can just drag and place it here. That's it. All right. That's it. So for example, this here, another convention that we said here is that we say that inputs and outputs are all identified by their addresses. So in TI portal, you have to be very specific. So this input here, we have to represent this. Let's say that this is a switch. So we can name it a switch, okay? Switch. That's it. Then this here, you can name this lamp, like what you have in your house. At least you have a wall switch and you have a lamp. So let's just call it lamp, okay? Lamp. But of course, you see this here, there's an error here because switch it's a keyword in TI portal. So let's just rename it to something like just S. let's just call it SW1 for switch. Okay, then you see that these two tags are underlined, and this is not a good thing. Okay, they're underlined because they are not defined in TI portal. So we need to define this. By defining this, we are just giving it a unique address. So remember, this is our first input because we are using normally open. Therefore, this is our first input. So we just write, you can just right click, then define tag. All right. And then you can define this as a global input, and the address is I0.0 because it is the first input. So the address will be I0.0, then just define that. And remember, lamp is an output, so this is our first output. So right click, then define tag, then select global output, then just define this. That's it. And now you can simulate this. So if we simulate this, this is what we have. So this switch one is normally open. You see, in TI portal, the green line here indicates power flow or continuity, okay? Then the broken blue line indicates no continuity. So with switch one, it is normally open. We said it's just an open circuit, so the power is not flowing to the other end, to the negative rail. But if we change this here, let's say that it's a proximity sensor and an object is detected. Once an object is detected, it will change the state from normally open to normally closed. That is what's happening here. So you can change this here. And you see that. So you see the power is flowing from left to right. In ladder diagrams, another convention is that when reading ladder diagram, you start from left to right hand side. All right. So that is normally open. What about normally closed? So what I can do, I can just change this here. Then I can use normally closed. Then I'll just download this program again. Load this, then change this here. Then take it to run mode. Just a minute here. Something happened. Yeah. How to change this here? So you see, with normally closed, it is a short circuit in simple terms. So the power will flow. So that switch is normally closed by default. Now, when the sensor detects an object like this here, we can change the state here. So it will change to normally open, therefore breaking the circuit. Those are the two concepts that you really need to know when you want to program using ladder diagram. You need to understand what is normally open, what is normally closed, and what is this coil here. So thank you so much for watching this video. Stay connected, subscribe to our channel, and share this video.